Okay. Okay. Many people I can see is from my normal batch. Trilochan, I'm correct, right? Anpurna, there are many students. Okay, cool. Guys, I'll give you opportunity at the end to raise hand. There is nothing right now to raise hand. I have not spoken except good morning to anything like that. Okay. So have some patience, have some good learning today, and then we will, okay, discuss on something, whatever you have. Okay, cool. So people are joining, but we are going to start. Okay. So good morning, everybody. Hopefully I have replied. Okay. Light, mouse and clear. Cool. Okay. So today we are going to have a session. Go down. Let me take this chat. Fine. Okay. So today we are going to have a workshop on basically AI and ML. Okay. So initially what we are going to do is initially we are going to understand some terminology, some basic understanding what it is, and then we will go into ML. Okay. Some different type of MLs, what are there. Then we will do a small workshop, small assignment we can say. I will do it for you. Okay. So basically we will design a loan system. Okay. Whether we'll design a model where the model will predict that a loan should be approved based on some data. Okay. So that is our end goal. So first we'll understand what is AI, what is ML, what is generative AI, agentic AI, some basic definitions we'll understand. Then we will understand what are MLs, okay, and why it is required, why there is so much hype, all those couple of things we will discuss it on, okay. And then we will see our project, okay, what we are going to discuss today, okay. So there are a couple of already I have taken some sessions. Mostly it was while I have predicted, and you might have seen right when a match is going on, you win a prediction. India versus suppose last match was New Zealand. So India win percentage 90%. New Zealand win percentage 10%. Okay. So how this changes, how we are able to predict. Okay. Already I have taken one workshop. Again, after this workshop, that will be our next target. Why? Today you will get to know something. So next time I will give you everything beforehand so that you can practice along with me. That is the end goal. And that is what we are going to target. So today, everything I'm going to discuss, we are going to do. I am going to design everything. In the next workshop, when I bring it, okay, we'll try to bring this and on the similar pattern, what we are doing today, we will try to solve this problem again. That time, okay, and that will be a real workshop where you also will be contributing. I hope I am making sense to each and every one of you. Okay, in between you can put yes, no, because I'm not a mind reader, right? Not an astro talk. So in between you can just put yes and no. At the end, whatever doubts we have, we will discuss on that. Okay. Now, before moving on to our topic today, I'll have a couple of things that I wanted to discuss. So before moving it, okay. So my name is Abhijeeth Kumar, and I'll be taking this workshop. Okay. So generally I teach in Naresh IT where I'm taking system design, okay, DSA, uh, different kind of topics which I have covered, which is my strength. Okay. Recently, there are like I will show you some of the openings that I have predicted long back. That slowly, the job what is coming is mostly full stack plus AI. This is the most demanding job in the future. Okay, this is the most demanding job in the future. So because of this, even my company, okay, I'll talk about me later on. So there are a lot of openings that are being uh, like has been put on the portal. Okay, so before moving in, So my name is Abhijeeth. I'll be the workshop or the person who will be taking this entire workshop. Okay, I have done my BTech from VIT Vellore. I have done my MTech, that is Masters, from IIT Delhi in computer science. Okay, I have worked in different organizations, example, Bank of America, Goldman Sachs, and also I have worked in State Bank of India as a government employee. Apart from that, I have worked in a good startup that is APN. Okay. And I have been working in Amazon now. Okay. So my role is P4 role, where right now this is the task that I am performing. Okay. The role which I'm putting up to you, this is the task which I'm performing right now in Amazon. I am working on Cairo model, which is which is used by Amazon Q. Okay. That is our AI. Okay. And it is built on AWS Bedrock and all. So that's a completely different thing. But yeah, this is all about myself. Okay. And I have multiple batches running on related to DSA and system design. You can find some DSA workshops available, solid principle workshop, system design of some YouTube, all those things I have taken up. Okay. Apart from this, I am also a mentor in, not a trainer, I'm a mentor. Okay. Available in Geek for Geeks. And I have been teaching into different big edtechs on weekend where you go and pay at least this much amount of fees. Okay. So all this model, whatever is there, I have brought accordingly, and same course we are launching there also. And that is where here also I am bringing that same course. The course is going to start on Monday. This is called as DSA plus AI engineer. So all the rounds which we take, every round I am going to cover here. That is first two rounds. If you come as, you will be clearing your technical round, DSA rounds. Then you will see some AI rounds and one system design round. System design will be a bonus. After covering DSA plus AI, I will give a 10 days long workshop where I will be, for all my students, we will be having system design concepts. And we'll see some system designs of like YouTube or Netflix, how you are getting a recommended systems. Okay. How you are getting recommended that, okay, this movie you should watch based on what taste, how that model has been built on. Okay. So all those things we will discuss in this particular batch, friends. So this batch is definitely going to take you more than around easily 5 months. Okay. Plus minus 5, 10 days, you can take it, not minus, plus and all. Okay. So anybody interested, free demo is there. You can definitely join in. Okay. So that is one of the agenda that I want to discuss. Fine. Let me see. Yeah. And SAT has also posted out. So you can go ahead, you can do it. Now, one thing, before doing anything, okay, before doing anything, any work you do, please do with your proper heart. Don't just open your mobile and see the videos and just relax it out. Do everything in a proper manner which you want to. Okay. So I'll tell you a couple of things about me before moving onwards. If you see, okay, if you see, people call me a little bit of different idea. I was like, people don't like it. Okay? You can see, okay, when I have resigned from SBI, I have left a government job, guys, and it is based on my choice because I knew I can do better than that. I have qualified in my time for IBPS. Okay, I'm basically from Bihar, so government job is like a god there. Okay, you need to have a government job. Recently, I have also qualified. You can understand my routine and you can see that I have also qualified for Public Service Commission. This is my state, yes. How I am able to do it? Because of the discipline of the routine that I follow. Okay. And that we'll discuss it in some other time. First to tell you that discipline and by focusing a little bit, you can do anything you want. Okay. Please don't cry on small things. Package of 10 lakhs to 12 lakhs. People who clear Amazon, Google doesn't comes from different planet. They are among you only. Only thing they have put an extra effort. They have went into proper discipline channel. Okay. Not watching reels entire day. I also do that, but there is a proper time available. Okay. Now, without wasting any time, let's start our topic today. So, What is AI? Okay, a simple definition I can put it as AI is a branch of computer science where we will enable our system to perform a human level intelligence. Okay, or I can say that it's a field of computer science that are going to build some systems that perform tasks that requires actual human intelligence. Okay, now traditional computer science, if you see, okay, what we do, a developer is going to write some program. He is going to give some instruction. Okay, if suppose A is greater than B, okay, then A is this. Okay, else this. So what you do, you define some rules, you define some instructions. Based on this particular instruction, your system is going to work or system is going to perform some task. Okay, it is going to analyze something. Instead of hard coding every rule, what AI is going to do for you is AI job is to learn the data. Okay, AI is going to do all these things, but by using your data and some algorithms, we will see that. Okay, so if I give a correct definition, AI is a field where computers are designed to learn from data and actually make decisions like human beings. So instead of we give computers the exact rule, okay, if this is equal to this and do this, they have to do this, blah, blah, blah. No, we actually provide them some data. They analyze this data, they find some pattern, they do some analysis, they train themselves on this data. And by doing all these activities, then they are able to predict things from you. Then they are able to decide things on your behalf. Okay. So whenever we say that AI learns patterns, it means computers is going to find lot of mathematical relationships between the data, and how they do it? They do it using machine learning. Okay. So a very famous analogy. Okay. So very famous analogy is that there are multiple analogy available. So very famous analogy is that, okay. And suppose you are a student, okay, and you want to write some exams. So what teacher will do is teacher will give you previous year questions, and on previous year questions you will analyze, you will see what kind of questions are coming, what are the correct answers related to this, and based on this you will appear in the exam. Okay, so this is how you are able to predict the answers. Okay, you are going to predict the answer in the exam. This exactly is AI. So AI can be used in multiple places, spamming, email detection, all those things. We'll see that. Okay. Loan approval, diagnose health, and blah, blah, blah. What is generative AI? Generative AI is imagine that same teacher is asking the student, hey, can you write something about Abhijit? So now, instead of memorizing things, what he will do is he will analyze those patterns and create a new content based on that. So whenever a new content AI is able to create, that is called as generative AI. That is, they are able to see the word generate. If they are able to generate some contents that can be text, image, music, code, whatever it is, that is called as your generative AI. Okay. One by one, we will go into before jumping into our project. Okay. Then there is something more advanced thing has come that is called as agentic AI. What is agentic AI going to do for you? It is a little bit more advanced. So if the student gets to do an entire project, so what he will do? He will go search books, collect informations, make some slides, make some PPT, do the presentation, and okay, consume all this task for you or do all these tasks for you. So this is able to, agentic AI is able to do entire thing independently to complete this task. This is called as agentic AI. So AI, what happened? You are able to predict answers from existing patterns, what you have seen. Generative AI, you are able to generate new contents. Agentic AI, complete end-to-end thing without taking any other help. Autonomously, you are able to work independently. Okay. So this is called as what? AI, generative AI, and agentic AI. So AI is what? It will think. Generative AI is what? It will create. Agentic AI is what? It will act on whatever it has learned. Okay. Fine. Now, our today area of interest is machine learning. Okay. So what is the role of machine learning inside this AI? Okay. So machine learning is a way to build your AI systems. Okay. So AI is an overall concept. AI is your end goal. To achieve that particular goal, ML is going to help you, or you are going to use machine learning to achieve this particular goal. So that is what is called as machine learning. Understand simple. Machine learning. Machine will learn. From where it will learn? It will learn from the examples. It will learn from the data that you are going to provide to it. Some algorithms which you are going to write for it. Okay. So that is what it is. So AI is idea to make some machines quite intelligent, and to build that particular AI, that AI system, we are going to use a technique that is called as machine learning. Machine learning is not the only technique available. There are multiple other techniques available. There are some search algorithms available. There are some logical systems available. There are some different optimization systems available. Machine learning is the best among them. So that is why we are going to use machine learning. Okay. Now, the best example which should actually give you a good feel of it is now, suppose anybody has a kid or a brother or a sister. You want to give him a full education. Okay. You want him to crack IITs. You want him to crack NEET. You want him to crack government exams. Okay. So ultimately, the job is that you want to provide him a good education. Okay. You want to provide him a very good education. To provide this good education, okay, to provide a good education and make him an independent person or a human being, what he has to do? He has to go to schools. He has to read books. He has to solve problems. Okay. And he has to pass the grades, all those things. Okay. All these particular things, he has to do it. Okay. So your end goal is to give him the education. So this can be your AI. To achieve this end goal, you have to undergo some process, or you have to use a lot of techniques, right? Read the book, give the exams, do this, solve the problems, understand things. So this is going to be your machine learning part. To achieve AI system, to achieve your end goal, you need some techniques. Directly, it will not do anything, and that is called as your machine learning. So, machine learning definition, if we come, it's a part of computer science where we teach computers to learn from data, find some patterns, and make decisions or predictions. Okay, that is what is ideally your machine learning. Now let's compare machine learning with our traditional computer science. So traditional computer science was what? You will write a program, you will give some input, you will get some output. That is what you do. In DSA, any program you write, you are going to give some input, you are going to get some output. How you are going? Because you have defined some logics, you have defined some programs, some algorithms. This is how we have been, or this is how our mind has been trained. What machine learning is bringing this or something new to the table is that this is your machine learning where you have written some algorithm. Okay. So what it does, you provide input as well as you provide output. You provide input as well, you provide output. Using this algorithm, using this logic, using whatever you have written, it will find out, or it will have its hypothesis. It will have a hypothesis, or it will define or it will find some relations between the input and output. That is, if this is the kind of input, this is what the output is. Example, you can imagine as if the credit score, okay, if your CIBIL score is more than 650, he identified from the input, generally the loans are approved. If your income is like greater than 1 CR, I can see that the loans are approved. So you have the input, you have the output. Generally, you might not have output also, but we'll see that later. For now, keep in mind that you have input, you have output. You give this to your machine learning, it understands, it generates some hypothesis between input and output. Okay. After you get this hypothesis, my dear friend, now your machine learning is ready. Okay. It has learned from your existing data and it is ready to give predictions. It is ready to do the decision. This example now should clarify everything for you. Imagine you go for IIT preparation, okay, or UPSC preparation or any kind of exam in India. Okay. What does you do? You go to a classroom training, any training. The teacher teaches you some concepts. Okay. IT, you have differentiation, integration, anything concept you might have learned from there. And you will solve a lot of problems. Is the same problem coming in exam? Is exactly same problem coming in exam? Can any teacher guarantee? Is there any teacher who can guarantee that no, this is what I have taught and it is going to be, okay, it is going to be the same. I have given you 100 questions. These 100 questions will come in IIT. Is it like that? Has anybody seen that? No. But he has taught you the patterns. He has taught you that this type of problem, the solution will be done in this particular way. So he has trained you for 1 year, 2 year, 3 years by giving you tools, by giving you data, by teaching you, by training you. Same thing, my dear friends. What we have done to machine learning is we have given him a lot of data. We have given him a lot of data and we have trained him on that particular data. Once he is trained, he has understood the data, he has understood the relationships between different inputs, different outputs, different parameters. What he's going to do? Then he is going to, even if he gets something new, he will just go back. He has already learned those techniques. Now he is able to solve it for you. Even in our class, when you come, suppose I am teaching you DSA. So I can solve you or I can train you with multiple things. Okay, DSA has 14 patterns, it has sliding window, two-pointer method, trees, graphs. We will solve a lot of problems. Can I guarantee that you will get the same problem there when you go for interviews? Not. But what I have done, I have trained you in all those particular methods, in all those particular programs, so that any similarity or any kind of problem related to that particular topic comes in, you are able to write the answers. You have been trained, my dear friend, and that is what we are also doing. Did I make sense to each and every one of you? Okay, so always make things as simple as possible. Please don't go for all those heavy words and bookish definitions. Try to learn in a most simplest way. And that is what I have done my entire life. Okay, fine. Now, so ML is going to learn some lot of things from the data that we give. So suppose we enable our machine. What is machine? It's a system, computer. So the machine is learning. Okay, so machine is learning. I will give you option to speak up at the end, guys. Okay, there is a lot of things to cover. You will see today. We will create an entire model in front of you. Okay, have some patience. Okay, so we enable our machines to learn from data and it can give you predictions or decisions. Example, if you have spam emails, example, spam emails, guys. So what you do? if you are going with the traditional approach, what you will do, you will look into all those emails. Example, you have to look into 10,000 spam emails. Then you have to find some pattern, and then you have to write some logic that, hey, if this is going to happen, this is what we should do. If this email contains this, then do this, else do this. Okay. In traditional system, if I want to classify whether we have email spam or not, we need to read all those emails, identify where it is a spam, and write a proper rule to identify if the next email, whatever is coming, is a spam or not. But if it doesn't matches anything related to this, your system is gonna fail. And you cannot predict what spammers will give you. Spammers are more intelligent than us. Okay. So they will find new way to spam. Okay. Instead of this, okay, instead of this, if I create a machine learning algorithms, it can itself look into all the 10,000, 100 lakh K, whatever is available. We can train him. He will give him data. He can identify some patterns and start making decisions once it's trained. Okay. Now, you cannot tell my dear friend that it will always make 100% prediction. Nobody can be 100% right. But we have to make a model which is good or accurate. Okay. Fine. So we have understood what an ML is. Now, what are the ML types? Put in chat if you have any doubts, my dear friend. Okay. Otherwise, more than 100, I think 200 plus students are there. If I allow everybody to speak or unopen, it will be like a parliament where people will come and fight and it will be a chaos. Okay. Now, put in chat whether you have understood. Just respond in between because again, I am not a mind reader. Okay. Whatever you tell me, I understand from there only. Okay. Tomorrow we can have a machine learning which can actually identify and read your mind. Hey, he has understood or he has not understood. Okay. We'll plan that. Fine. So how many types of MLs are there? Okay. So there are something called as supervised learning. There is something called as unsupervised learning. There is something called as reinforcement learning. Okay. So there are three type of ML that is available for you. Okay. So let's see what is a supervised learning. So supervised learning is nothing but where we have, this is supervised learning. So where you are going to have a labeled data. Okay. And our machine is going to use this labeled data. What do I mean by labeled data? Labeled data means that where you have input and for that input, you have the output. Okay. Example, you have an email. So for that email, suppose one email is there, you can categorize that it is spam. If another email is there, you can categorize it as not spam. Okay. So we know that email is either spam or not spam. That is or not spam. Okay. Another example can be, suppose you give him the machine the image of truck and you tell him, hey, if this kind of image comes, this is a truck. If this kind of image comes, this is a car. Similarly, you can train him on different cats, dogs, that hey, this type of image comes. It means you give him the image that this is cat image, this is dog image. So next time when he sees a cat or a dog picture, he can identify this is cat, this is dog, and he will tell no, this is not a cat, this is not a dog. Okay. So label data as data that has a proper outcome, you know the exact outcome. Okay. So whether it is a spam or it's not a spam. Inside label data, that is, sorry, inside the supervised learning, we are going to solve the problem in two ways. First is called as your classification problem. Okay. What happens? Where we classify the output. Classify the output in the senses. In your email content, let's take the same example. Your email content can be different. Can you predict that the spammer email will be same always or will have some pattern? You can't. The email content, that is the input, is going to have 100 characters, 200 characters. That email can have different subject, different body, anything. One word, 10 word, different senders. You can't predict. But one thing I know that either that mail will be a spam or it is not going to be a spam. Okay. This is what I can definitely guarantee. So classification means where you have classes, fixed classes, or you have fixed categories. That it's a spam or it's not a spam. Okay. So input, output you have available positively. Okay. So finite set of output you have wherever you have finite set of outputs available. Like in this case, we have what? We have in spam or not spam. Like in your matches, whether it is going to win or lose. You have a fixed set of output, not some random output. Okay. Second is your regression problem. Regression problem is where you have continuous value. Okay. Continuous value. Example. Suppose I have lot of data for my weather condition, or I am going to use my weather condition to predict what is the AQI. AQI has been very much important nowadays. So what is my air quality index? So air quality index output, can I predict it will be only 32 or only 100? It can be anything ranging from 0, 1, 45.5, 46.6. So it's a continuous value, it's a continuous range. You cannot classify your output. Here you are able to classify your output, that it will be spam or not spam. It will be a win or not win or lose. It is approved or not approved. In this, you cannot predict, or it will be a continuous set of your output. Okay, you can have infinite values. Example, stock prices. You cannot predict that what will be the stock prices, whether it will be 100, 200, 500, you cannot. Okay, so this is your supervised learning. Okay, this is called as your supervised learning. Unsupervised learning, unsupervised learning is where you need to deal with unlabeled data. Okay, you are going to deal with unlabeled data. So here what we are going to work on, you are going to work on clustering problem. Okay, you are going to work on clustering problem. Okay, so clustering problem is example, see Amazon. Okay, in Amazon, I can find the pattern. I have created some machine learning and I will find a pattern that, hey, some people who are buying iPhone, they are also buying a charger, or they are buying a case, or they are buying a scratch card. So with this, I can identify that, hey, people who are buying iPhone are definitely buying these accessories. Car, people who are buying this car are definitely buying these accessories. Anything. So what we can do is anytime a new user comes in, I can suggest him that, hey, please, or whenever he buys some iPhone, I can suggest him that these are the accessories, my dear friends, that you can, or I can suggest them those accessories. You might have felt it. You go and select that, okay, I want to buy an iPhone. In between or in the down, you can see that, hey, you have a recommendations that people who bought this also bought this. Okay, please go every time you see it, observe all these minute things. Okay, so here what we are going to do, people are going to find these patterns from the data that has been provided. So what we do, we collect and organize same type of data together. Okay, example, there are smokers and non-smokers. So we identified that people who are smokers have lot of lungs related problems. Non-smokers, we find rarely some runs-related issue. So smokers, we will cluster them in the same data. Non-smokers, we can cluster them into same data. So cluster means combination of something. Third thing is your reinforcement learning. Reinforcement learning is nothing but your goal-oriented learning. Okay? Reinforcement learning is your goal-oriented learning, where we have well-defined some target available. Okay? It's generally used in your robotics. Okay? Actually, it's like training a pet and all. You give them some commands, they are able to follow these commands, and you are giving them some rewards. So in this particular algorithm, whenever they do something correct, we reward them. If they do something wrong, we punish them. Whenever we punish them, they understand and they train themselves on this correct or the wrong method. So slowly, slowly, they become a good models. Okay. So now we will jump to our workshop today. I hope you have got some idea of it. What is AI? What is machine learning? So today we are going to have a supervised machine learning model that we are going to create it. In this, we are going to create where we are going to predict whether a loan can be approved or is it correctly approved or not approved. Okay. So it can be categorized as supervised machine learning because I have a output available for me. Okay. We will have some inputs available and based on that inputs, we will see. Okay. Fine. So for that, I have a data set available for me. I will share all this data set. I will share this entire code that we are going to write in the form of PDF, Excel, and you can practice it at your home. So let me see where I have the data. Let's make it. So reinforcement learning is learning where you are going to have a fixed goal or a fixed target. Okay. You know what is your end goal. Okay. So definitely robots. Robots needs to drive a car. You know that. Robots has to drive a car. Okay. So generally how they train it, and it's rarely used in our IT industry. Mostly it is used in different embedded systems and all. But still, I've just put it. Mostly we'll go for supervised and unsupervised learning. But here is that you give them commands. If they do correctly, you provide them rewards. Do something wrong, you are going to punish them. Slowly, slowly, they train themselves and they start giving good predictions. Okay. So this is what the data we have. Okay. So we have applicants, we have their employment, co-applicants, status, what is their credit scores. Okay. And we have a output, whether the loan has been approved for them or not. So it's the supervised learning data that I have. The input is there, the output is there for me. Okay. So for this kind of data, the loan is approved. For these kind of data, the loan is not approved. We are aware of that. So this is the data set that I am going to use, my dear friends. Okay. Now, where to code it? So ideally, there are a lot of environments in the classroom I will teach you. But if you want to practice it nicely, I have opened it. Okay. People might be aware of. It's kaggle.com. Okay. And here you can go ahead and create your own notebook where we are. This is an environment where we're going to write our codes. Okay. So you don't need to install anything. Just go to kaggle.com, register yourself with your email or sign in with auth. Everybody might be knowing auth what is. So Google. Okay. Or any Facebook or Instagram. There you can go ahead and create a new notebook from here. And this is what screen you are going to land into. Kaggle has a very good benefit since it has a lot of default data sets also available. Okay. Next time when I'm bringing that workshop and I'm going to predict a match winner, okay, we'll create an ML which will be mostly to predict a match winner. Okay. So in that we will use the data set from Kaggle itself. Okay. Fine. So let's start our coding part. Fine. Okay. So this is what we are going to do. So before doing everything, you need to give them what data he has to be working on. So if you are not going to use Kaggle dataset, we are going to give it from our dataset. And let's give me loan approval data. Loan approval data. That is fine. And let's okay. So my data set has been created. Okay. So my data set has been created, my dear friends. Now, if you are working on Java or C++, C Sharp, C.NET, whatever it is, you are going to import lot of libraries, right? Import java.util.star, import java.this, import this package, import arrays. Here also, we need some libraries to get imported. Okay, we are going to import some libraries, my dear friend. What are those libraries we are going to import? Let's go ahead and delete all these things. Let's delete it. Okay. It's anyway commented. So we are going to import very important thing. If anybody has ever worked on, it's pandas, and let us add this PD. Then let me import. I will tell you what is the usage of this. NumPy as NP, that is fine. Just importing some libraries. Don't think of anything else. Okay. Something machine learning does extra. Nothing it does. How you have programmed everything, it is going to be same only. Yeah. There will be something different here and there, but that's okay. Seaborn. Okay, fine. Let me import as plotting. Okay, I'm going to plot some graph. So let's have the EY plot and let me name as plotting. Okay. Now I can have, I'm going to use sklearn. Okay. So you don't need to write everything from the scratch. sklearn is available, which will give you all the codes. That is, it has already a lot of models available. You can use that. So model selection, and let me import to train some data. Okay. So sklearn. Okay. I have chosen and all this library. Okay. So what are these libraries used for? Okay. So what are these libraries used for? So Panda is used generally for your handling and analyzing some data. Okay. It helps you to work out with different data sets, different tables, understanding those tables. Okay. Importing those data. Okay. Right. You write an SQL query and all right. Select star from this much data I need. All those things you are going to have it up. NumPy is nothing but it's a numerical. Okay. It's a numerical computing and faster mathematical operations it can perform. Okay. Generally, in a normal life, you have arrays. So here it is difficult to use arrays because it will be very much slow. So NumPy is going to give you very fast mathematical operations and calculations. Okay. So generally used for your mathematical calculations available here. Cool. Now there is Seaborn. Seaborn is which will give you very beautiful graphs. Will plot lot of beautiful graphs. Okay. So you can plot bar graph. You can plot. Okay. You might have done right histograms, pie chart. Even in your 10th, 12th, you might have heard of these things, right? It's nothing new I am going to talk about. So this is going to give you those particular libraries. I need some yes in between if you are having any doubt. Okay. Now matplot library is something which is going to again work with Seaborn and help you plot these kind of graphs that we have talked about. So these two works in tandem and help you in work with that. Last is I have imported sklearn, very, very important. Okay. This is that library which will help you to split your data into your training data and your testing data. You can't give everything to the model. You have to segregate that his uh, model. this is the data that on which you should be trained. And there will be some data for you which you want to test it. So this is where it is going to help you. Example, you have 80% data available. In this data, you should be able to train yourself. And then you will keep 20% data for you to test it. Hey, whatever you have trained, are you going to give me correct answers? Is it correct? So first you have to train them. So to train them, you have a separate data. To test it, you have a separate data. So what I'm going to do, this is going to help me in segregating my data into training data and testing data. Raising hands, I will give you at the last. Till this point, are you guys clear? If you have any doubt, you can post it here. There are a lot of students. It's very difficult if everybody starts speaking up. I need some more answers. Okay, again, we will create a machine learning model in our future where I can read your data or read your mind. For now, I cannot. So to start forward and to have this workshop is interesting, you should be able to understand the initial steps. We'll try to make it as simple as possible. Okay, are we all good? It's a library that will help you to split your data. Okay, suppose you have a table available. So entire data, you can't give them to machine learning. So you have to bifurcate that for machine learning. Okay, I will give you this. It's not the only approach. There are a lot of benefits available for it. But for now, this is what I am going to use it for. Okay. All the data, suppose this entire data, whatever I have given, all this data I'm not giving to the machine learning to train himself. What I'm going to do, I'm going to segregate some data, like I'll tell 70% data should be for training. 30% data, I want to give it for my testing purpose. So this model will help me in distributing it and giving to the machine learning what it requires. That's the job of sklearn. These are all the existing libraries that has been created to help you. Fine. Now we are going to do the next step, that is EDA. Very, very important terminology. A lot of places you will heard this. Exploratory data analysis. So first, before giving to machine learning, I have to think that what my data is, what my data relations are. Is my data correct also? Is there something missing also? So to do this, you have to do something called as exploratory data analysis. You have to explore your data, analyze your data. So it is going to make you explore and understand a data set before you build a machine learning model or you give it. So before training a model, we have to understand what data we have. Are there any missing values in that data? I cannot guarantee that everything data has been given has everything available. Something is missing, I need to check it out. Later on, we'll see whether the data contains some outliers. Outliers in the sense, understand it in a simple terminology. This outlier terms will come multiple times. Imagine I have a data set where 99% of my applicant income who is applying for a loan ranges the income between 20 to 50 lakhs. Only one or two data I have, which is where the person is like me, who is having 2 crore package. Okay, his salary is 2 CR. So this data, who is like an outsider, these all are common. Okay, they all mingle together. This is the outlier data. Okay, so it will help you to analyze all those things. So right now we will do our EDA. Okay, so let's do that. Fine. Okay, let's start our EDA. So before doing that, I need to have create a variable that is data frame. What data frame will do? It will ask, I told you, right? Pandas are used to analyze the data. Okay. It is like to bring in the data. It's like you have JDBC connection, right? In your Java, which will bring, then you will put SQL.connect, SQL.write some query. So this is what I'm going to do. Okay. So ed dot I can tell him, hey, read this CSV file. So CSV file, you can just go here, copy the file path and paste it here. Okay. So this is cool. This is fine. So let him, please don't go slow today. Oh, my bad. Okay. So since I have not executed this, first I need to execute it. So my environment will import all these things. That is what I'm afraid about Kaggle sometime. Finally. Okay. Now let us do the same thing. So PD, that is, I am asking my pandas that read this CSV and keep it as a data set for you, like you do in JDBC or your normal terminology. So here I already have that, right? Yeah, fine. Now let's run it. Okay, it's run. Now to test it out, let's have, there's a command called df.head. Df.head will give you what? Head means always top. So from top, some 5 data it will give you. Can you see? We have our top 5 data available. Always head means what? From top you will get something. Head is what? In our top. So top 5 data you have available here. So I have successfully connected to my data set and I'm able to pull the data set and now I'm ready to work with that particular data set. Okay. Now let me see any doubt. No. File extension can be anything. If you have anything else, you can give some other files. It's not to be need to be a CSV only. Okay. It can be anything. Data source can be anything. Okay. Fine. Okay. Now what we can do is let's have some more detail about our data. Let's see. So you can get the info. Let's run it. So you will have the info that how many columns you have. Can you see? I have applicant ID, I have applicant income, I have co-applicant income, I have employment status, age, credit score, blah, 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 loan approved status. In this, one very interesting thing you can see, non-null count. That means I have total 1,000 entries. Okay, total rows are 1,000. In that, 950 rows are completely filled. 50 data is null data. So in EDA, we have seen, right? Any missing values, we have to take it. Then you can see there are different data types available. So I have float means integer. I have some objects, so it belongs to some categories. Okay, so this is what I can understand from my data. Fine. Now we will see, okay, what all or what all null data I have. So let us see that. So you can see that every column has 50-50 data as null. Every column has 50-50 data as null, my dear friends. Everybody can see this? Okay. So it is telling you that what all data is null. Give me the sum. He's telling you that yes, you have 50 data for every column that is null. Okay. And even though it is not required, just for your, so that you can understand more, some more commands, I'm just giving you the entire data set. Okay. So it will give you everything. Describe means it will give you the count, mean, median, mode, what is the max, value, everything. Okay. All those things you can get it here. Okay. I hope I am clear to each and every one of you. The next task will be to handle the missing values. There cannot be a missing values, my dear friends. Now for missing values, what you will do? Will you go to the customer and ask him, oh, what is your, suppose old loan data you have. You'll go and ask him, hey, what is your age? What is your mental status? What is this? Not possible, right? So, and this machine learning is not going to do all those activities for you. So what we will do is we will handle the missing values. Okay. By ourselves, we will calculate based on the existing data that what we can put there. It's all about prediction, so we will predict it. So the next step should be to handle all these missing values, my dear friends. Okay, so it will be all about your missing values now. Fine. Okay, so let's start with our handling missing values. So missing values, you can see that you have two options available. Two data types are available. One is your number data type. One is your object data type. So let me pull all those data types for me. So let me give as categorical, I can have, okay, columns. We call them categories. Okay. So whenever there is some kind of string or those data types, I'll call it categories. So tell my data frame now. Data frame I have already have, right? See, data frame I have already pulled up. So this is the way I can interact with my data. So df dot I can have select what data types I want to select. I want to select, let me have it as, okay, I can have object data type and give me all the columns which are object. Similarly, I will do it for my numerical. I've told you we have two type of data type. Data type, one is float, number, another is object. Okay, so here let me give the name as something, sorry, let me make it as numerical. Spelling is correct, right? And here I can give, here you can give float also. Okay, here you can give multiple options also, like you can give, what to say, give it like numbers, float, 64, whatever you want. But if you put numbers, it will be like calling everything same. Okay, all the numbers, float, int, xyz, all numbers, it will take it out. So I hope I am correct. Fine. Any doubt till this particular point of time? I can understand. You have understood. So we have data types. We have seen how to pull the data, how to work, start working with it. Okay. So here we are going to build a loan approval system. So either it will be yes or it will be no. So classically it is called as binary classification problem. We have read classification, right? Classification means your output is fixed, yes or no, okay or no, 0 or 1, 5 or 10. So this is a classical problem for us, that is classification problem. So inside that we have binary classification problem. Okay. So now we are going to do some data cleaning. That is what I have started up. I'm pulling my numerical separately, my category separately. For numerically, what we are going to do is numerically, I can say that, let's understand. So numerical data can be, so your numerical data will be like your, I can say age, okay, can be your applicant income, okay, your loan amount. So previously there might be that all these data are missing. So what we can do is we can actually calculate the overall mean, median, all those things, and we can put that particular data wherever missing is available. So based on whatever data I have, we will calculate the mean that, okay, average people are applying for 5 lakhs loan. So let me fill it 5 lakhs if the loan amount is not available. If the credit score is not available, okay, generally people who apply are ranging between average people, average means maximum people having a credit score of 650. So let me fill in that particular data. This is how you are going to handle the missing data. So all the numerical things, you can handle it through either mean or median, whatever you feel comfortable. Our case, we are going to take some average, so I am going to use mean. Can I do the same thing for my categorical data? Can I do the same thing for my categorical data? Categorical data in the sense gender. Somebody has not given his gender. Okay. In my data sheet, I don't know for one applicant, one row, the gender is not available. Can I go for mid and median? Is it possible? No, it is not possible. Okay. How can I calculate mean and median for male and female? So for that, we are going to use a concept that is called as mode. Mode is nothing but your frequent, mode meaning is frequent value. So we will see that what are the most frequent values that has been used. That is, suppose I have 100 data. In 100 data, 60 or 70% are females. So wherever the data is missing of gender, I will go and put females because the probability is higher. I am trying to reduce my errors. If I see that no, more people are into male, that is 80% male are only applying for the loans. So wherever these data are missing, I will go and apply male. This is how you handle missing data, my dear friends. Yes, Praveen, DSA means data structure and algorithms. Are we all good till this particular point of time? You can see my intensity is not going down. Neither should be yours. Okay, neither should be yours. Okay, so if we have done correctly, are we all good here? Let us run it. Does it run fine? Okay. Now here you can check it out. That okay. What are my categorical columns? You can see wherever your object, you are just filtering it, my dear friends. Wherever data type is object, you are filtering it. Okay, these are my columns which contains object. It is just like your SQL query where data type is equal to object. If you make it simple, it will be simple. Your employment status, marital status, loan purpose, property, education level, blah, blah, blah. Everything data type is an object. If you go for numerical columns, you can go ahead and you can run it. Okay. ID, income, co-applicant income, age, all those things are your what? That is your numerical thing, my dear friends. Okay. Fine. Next thing, what we are going to do is we have seen what all the things it is. Okay. We don't need this. This is just for your reference to show you how to work it out. Now we are going to use a library that is called as impute, and it will be provided by your sklearn. Okay, sklearn imputer. So you should have, is it the standard definition? Yeah. Have this. Okay, so you can see that imputation of missing value. So this is the library, okay, which is gonna help you in doing that. Okay, this is the library which is going to help you do that. See how they have done it. Missing value is this, and strategy I'm going to use is mean. If I want to use median, I will tell, hey, I want to use median. Okay, like this, you are going to do it, my dear friends. Okay, like this, you are going to do it, or this is the library which will help us in doing it. So the fill the data, sklearn is going to help us. Inside sklearn, you have something called as impute. Impute is going to help us in doing all this particular activity. You can tell your what your strategies, mean, medium, mode, most frequent. Okay, whatever you want, you can tell them accordingly. We can apply it and it will work for you. So let's go ahead and do that. So they would have done some import, right? Let's copy this. Okay, we can copy this, not a problem. Import simple imputer. Let's go to Kaggle. Fine. And first I can go for, okay, numerical one I can go. And I can use something called as simple imputer. That is what I have imported. Simple imputer. And here I can give my strategy. Since I have told you, I am going to use mean, or that is called as average. Okay. Strategy is equal to mean. Fine. And I am going to ask my data frame that, hey, for my numerical columns, okay, for my numerical columns, you can just go ahead and you can fit it. Okay. Okay, let me fit it, transform it, use my data frame. Okay. For what? For my numerical columns. Let me just copy this. I don't want to type all these activities. Okay, fine. So if it is good, okay, where is the problem? Numerical columns is not defined. I am using correct, right? Something spelling mistake. Okay, some spelling mistake, right? My bad. Okay. Similarly, what I will do is I will do for my category. So let me copy this. So numerical data I have done. Let me do it for my category. And it is, I am going to strategy as most frequent because it is critical data. So most frequent, that is fine. And instead of this, I can have categorical columns. That's it. I don't think we should need anything else. Let's run it. Okay, again, what mistake I have done? Simple computer, that is fine. Oh, sorry. It should be categorical, right? I copied everything, but I didn't change it. My bad. Again, what happened? My bad. Let me put it back and take it up. Okay, so strategy is equal to most frequent. Okay, then here I'm going to have as categorical columns. That is fine. Let's change all the things. Okay, so let's use our own variables. Looks like it is good. Let's test it. Okay, so df dot head. Okay, so we should have given some kind of data. How to test it? We have already a method to test it. I have already written. Let's see. Okay, can you see there is no null available right now? Every null has been replaced. Okay, yeah, most frequent is same as mode. Okay, most frequent is same as mode. Okay, so you can see, right? All those data is available has been settled. Okay, all those data has been done perfectly and positively. So I have handled all my missing values, my dear friend. Okay, so missing value has been done. Now we will find out. Okay, now we will find out the most important thing again. Still, we are into exploratory data analysis. Understand how important data is here. Okay, now we are going to find out. Okay, into next part, that is our classes are balanced or not. Classes means we have seen loan approved or approved. Okay, so is it balanced or not? Is it like 50-50 or no, 80%, 20%? What it is? Classes always I will depend or always will be related to your output. Okay. So that is what we are going to do here, my dear friends. What we are going to do? We are going for the next part where we'll check how balanced our classes is. Balance means whether each class has roughly same number of outputs, the model project is correct. Okay. So what it is? Let's see. Okay. Let's see. So imbalanced class means, example, I can put it as, suppose I have a data of 1,000. So spam is 50. Non-spam is 950. This is imbalanced. Okay, it's not balanced. But if I have some 400 and 400 and 600, I can say that, yeah, it is mostly balanced data. So let's check it out, what it is and how to check it out using some graph, using some analysis. So now our job will come to do that. So let's go ahead. And what I can do is, okay, so let me declare a variable that is classes underscore count is equal to df, my data frame. Inside that, what is that column name? Loan approved rate? Yeah. Let's take it up. Loan approved. And I want to take its value with count. Okay. Now I am going to plot. I told you, right? Plotting. I have imported library to introduce a pie chart. Okay. In the pie chart, I want to give my count, whatever I have calculated, and I want to give the labels. Okay. For people to understand what is no or yes. So if I do it, suppose no, and I can give it, suppose yes. And another thing, another parameter I can introduce is where I can tell them that just let me plug in my charger, friends. Give it 30 seconds. Yeah. So here I can just give a auto. Okay. It's a parameter where it will tell you how much till how much point you want to decrease. That is suppose 70.11%. So till what percentage value, decimal value you want to go. So I can give it as, let me put it as 1.1. And yeah, this looks fine. Let us run it. What is the error? Series object has no value counts. So that is my bad. Let's see any error. Are you able to see? We are able to plot the graph. And in this graph, I can see that, yes, it is an imbalanced class because most of the loans has not been approved. Some loans has been approved. Everybody, are you able to see this? These are, okay, these are the actual learning that you will have. Okay. So some heading is not there. So you can give this plot a title. Okay. You can give this plot a title that is loan approved or not. To understand it clearly, if you see this, see, you will have a title now. Is loan approved or not? And you can see that, yes, it is an imbalanced class, my dear friend. Similarly, we can do it for different parameters. Like educational is very, very important. So if I go for educational count, I can just write the same thing as, what is the column name of education? We have something related to education level. Okay. So we have to tell them that what is the education level. So education level is, I can have it. Dot value, I can get again the same thing that counts. And again, I can plot it. Okay. So I will use SNS this time. Okay. We have imported it, Cbond, to have some different kind of visualization. So I will use a bar plot. I will give this bar plot what? That is, I'll draw a bar graph. Simple thing. I want to draw a bar graph. And I want to give it a label as and whatever will be the first value, that is education. That is your count. Let us see this. Okay. So you can see that you are having a graduate and non-graduate level. Okay. See the beautiful use of the libraries that you have been provided. Okay. Similarly, you can do multiple things. Suppose I want to analyze the income. Okay. So now already I have, and this time I will do, I'm trying to give you different plotting so that you have an idea. You can use the same thing everywhere. Doesn't matter. So let's have a historical histogram plot. Data, please use my data frame, which I've already imported. Okay. My x-axis should be my applicant income. I should have my applicant income. Yes, that is the most important thing. Applicant income. Okay. And I can have like, okay, give me up till 20. So let's run it. Okay. And you can see that my applicant income, the range is mostly here. This is the highest range that I have. Like this income are the people who are mostly applying for loans. Okay. So one by one, we are keep on getting different data. Similarly, you can do it for co-applicant income. So instead of this, I can just give co-applicant income. This is fine. Okay. So co-applicant range is between this some 5,000, 6,000 range. We have seen it. Okay. Now we will check one of the most important thing, that is outliers. Remember I talked about outliers in the very first instance. So we have to plot, okay, an outlier. That is, it will be used something called as box plot. Box plot means we will draw some box. If somebody box is lying outside of what in the range is not there, we can identify, I got my idea. He is my outlier. So I need to determine a box plot. So again, I will take the help of my C bond, which is my data visualization. So just you need to draw a box plot. So definitely my data input is my data frame, which I have already imported. I have the habit of, okay. Now here what I'm going to do is I am going to see my x-axis is loan approved and between my applicant income. So what I'm doing, I'm trying to see the relationship also that hey, the people whose applicant income is what range who are getting more approvals. Or is there anybody who is like lying sidewise or somebody is like that? So let's go ahead and put it. And with this data, you can see that my box is quite intact. I don't have, like you will get some small boxes or something different. I don't have. Okay. So loan approval people are between this income range. Okay. There is no outlier that is available for us. We have to check, is there any outlier data? Is there any data with like 100 rupees income is getting his loans approved? Is there anybody with 5 crore income getting his loan approved? So that is what relationship we are drawing. So we are into EDA, my dear friend, that is exploratory data analysis. So like this, we have to do it with what all things are very important, guys. In a loan, applicant income, then your credit score, then your DTI ratio. I have a column that is DTI ratio. DTI ratio is what? Debt to income. Already, if you have lot of existing loans, will any company give you loan? Will any bank give you loan? No. Then they can check your savings. Okay, you have 10 lakhs in your account. Sure, I can do it. So let's do for all of them at once. So let me go ahead and do it for, okay. Let's plot some subplot 2 comma 2. And let me call all my SNS. So once I will draw a box plot. So let me give AX is equal to axis. What is happening? 0, comma 0. Okay. So let me have data is equal to df. My accesses I will prepare as same thing what I have done. I'll just put in a group. That's it. So x is equal to, let me have as loan approved rate. If any wrong data, we'll see. Y is equal to applicant underscore income. Okay. So I'm just drawing the box plot and let's do it for some 3, 4 important things. So I can have all the combinations and let me put all these things as fine. Definitely accesses is loan approved, but what? With what credit score is like, what are those people in those range, in those income who are getting their loan approved for that? People with what credit score are them who are getting the loan approved? Okay. So credit score is fine. Then I think we have some debt to income ratio. I also don't remember it. Yeah. I have something called as debt to income. It will tell you, hey, how many loans you have existing. And you can have your savings. Okay. I think we have done correctly. Okay. Access is equal to plot dot subplots. Okay. Let us run it. See, at the since you can see and you can check for your outlier. We are checking for the outlier data and some relationships. So we can see that these are the applicant incomes. Okay. From where you are getting, okay. Between these applicant income, you are getting some no, from some yes. So from applicant income, you actually cannot guarantee. It is getting rejected also, same data range, getting rejected also, getting approved also. Credit score, you can see some variation. Okay. Credit score, you can see some variation that people with this above credit score are getting their loan approved. Similarly, for debt to income ratio, you can see that. And similarly, for loan, you can see that. Okay. So all these data are where we can actually do it. So we have seen from here that credit score is very, very important. So let's understand the credit score or let's give our model credit score, which is very, very important. So let me draw a histogram plot. Data is equal to, already we know, this is a data set. X is equal to credit score. Okay. And then let me have as loan approval. That is how many people have got loan approved. Generally, in what credit range are we getting our loan approved? And let me pull as multiple data. It should be there. Okay, so multiple, I think it looks good. If any mistake, we'll see. Okay, what is the problem? Data is DF, that is fine. Credit score is fine. Loan approved is fine. Sorry, histogram plot. Hey, histogram plot, right? My spelling, please let me know if any spelling mistake is there and we can see. Okay. So your loan is getting approved if you have a credit score between this. Before this, none of the loans are getting approved. So the most important data that is here is your credit score. Okay. The most important data using, you can create your that is your graph by multiple use. Okay. You can use Tableau also. There's nothing problem in doing that. Okay. Fine. So second important thing can be our applicant income. So let's just do this. And instead of this, I will just give as applicant underscore income. And applicant income, I'm not getting any surprises, even with less rupee, because he might have applied for less amount of loan, only 10,000 rupees loan. So with applicant income, I can say that it's not guaranteed. Anybody is able to get the loan. So applicant is not that much important data. Now, do you think in our column, is there, or in our data set, is there any column which is not required for my machine learning? Do you think is there anything which is not required for my machine learning? Gender is required, right? Applicant ID. Do you need anybody's old application, loan application ID? Is it any contribution to us? Not at all. Okay, we don't need that. So what we can do is we can drop off. You drop the table, right? You drop the database in your normal SQL query and all, same thing. So just let us drop it off. Applicant ID I have given, correct? What is it? Applicant ID is not found in Access. Why? Applicant ID is already not. Have I dropped it? Yeah, applicant ID is dead, right? Spelling is correct. I have a big problem with spelling. Take the column name, applicant ID. Let me put it. It's correct only, right? df.drop applicant ID. Okay, fine. I don't feel any kind of mistake. Okay, we'll see this later on. We can delete it. Okay, don't want to waste much time on this. Okay, now the next important section that we are going to jump into, and the second last is after this, we'll train the model immediately. That is encoding. Okay, what is the purpose of encoding? Okay, why do we use encoding here? Okay, or you can say that if what will happen if I don't do the encoding? Why we need the encoding? The problem is machine learning is mostly about mathematical numbers. Encoding means you are going to convert into some kind of code, that is into some kind of numerical values. That is the meaning of encoding. So machine learning models mostly understands your number. They are very good with numbers. But if you give them male, female, text values, it is difficult for them. Okay, they take time to process all these things. So what we can do is we can convert these things into some mathematical values, but we won't convert them just like that. Okay, we won't convert them just like that. There are two kind of encoders that are available, my dear friends. So one is your label encoder. Second one is your one hot encoder. Okay. So what label encoder does for you? What it does it will assign an integer value to your category. See, numerical data, I don't need to change anything. Where I need to focus on my categorical data. So categorical data, what it will do, it will assign a number to your, that is your categorical data. One hot encoder, what it will do is, it will create separate column for each category. Let's understand it. Okay, let's understand it. Suppose you have male and female. Okay. So what it will do is if you go for label encoder, wherever male is there, it will assign example 0 value. Wherever female is there, it will assign some 1 value. Okay. And it will replace those particular idea. What? Okay. Example, tomorrow you have something called as red, blue, green. So red, it will assign 0, blue 1, green 2. And it will replace this in your data set. One hot coding, what it is going to do is it is going to create separate column for each category. So for gender, it will separate it. So male will be a separate column now, female a separate column. And wherever male was there, it will assign example 0, or female was there, it will assign 1, or it will leave it empty. So like that, it will do it for you. So it will create separate column for the categories. And in this case, it will create what? It will do it, or it will update the existing column, the data there. Okay. So this also we will get it from sklearn. If you go to sklearn and coder, you can see the official documentation. Okay. So in this, you can see that you have label encoder. Okay. So you're going to import it. You are going to do blah, 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 all those activities. Okay. And then you're going to fit it, transform it, all those things. Some parameters are there that you can read it up. But this is what your particular option available is. Okay. So first we will go for, or we will see the, what to say, label encoder. So label encoder, just now I have told you, it is nothing but male, female, you will assign some value. So wherever you have gender column, so instead of male, it will assign some 0, female, it will assign some. A new hot coder, it will create a new column. It is male and female. So suppose 0, 1, 1, 0, like that, it will keep on giving the value. So assign an integer to each category, create binary column for each category. There is two important terminology that you have to understand in label encoder, or this is label encoder is generally ordinal data. Okay. One hot code encoder is nominal data. What is ordinal data and nominal data? Okay. Many people have failed to understand, and even they don't main focus on this. So label encoder is about ordinal data. Ordinal is what? Order data. Okay. Order data. Data which exists in proper order. Example. Okay. Suppose if we take gender, for male, you have assigned 1. For female, assign 0. Are we trying to say that male is superior or female is inferior? Is my intention that? Is my intention that? No, it should be nominal. Nominal means you have to treat them equally. Based on this number, I cannot tell this is inferior, this is superior. It cannot be that case scenario. Okay. So one hot encoder works with nominal data. Label encoder works with ordinal data. Where order is important. Order is important in the sense educational level. Imagine your educational level friends. Suppose somebody is undergraduate, somebody is postgraduate, somebody is PhD. I have arranged them in an order. Can I say that yes, 2 has more weightage? Yes, this is more priority. This is more important. Then this is. Then this is. I have to give more weight, more emphasis on this if the score is more. But in this case, I should not be bifurcating this. Everybody clear? So in our case, we have to identify what are ordinal data, that is, what can be label encoder, what can be one hot encoder. Okay. So wherever we want nominal data, we want equal, that is male and female, they are equal. Deciding by number 1 or 0 doesn't tell me that male is more prior and female is less prior. No, no, no. I cannot do that. And it's not the ultimate goal. I hope I am clear with everybody. Okay. Are we all good till this particular point of time? So let's go ahead and do one by one. We will do fast coding. So let's go ahead. Yeah, where is my cable? Yeah, before doing that, let me see df.head. Okay. So like metal status, married and all is there. Okay. And these are all your categorical data wherever your strings are attached. Okay. So let me have all the data in front of me. Okay. So these are all the columns. And let me have the info. Then let me decide what to do. Okay. Now what I will do is first I will go for, or we can go for encoder data, or let's identify this first. Let's analyze the data properly. So sklearn level encoder, one hot encoder is not there. Okay, let's import this first. Let me import it fast. Another 20 25 minutes, we are done, guys. You have kept a very good patience, and it's a big topic. Okay, ideally, I want to discuss a lot of things, but okay, a lot of things can't be done everything at the same time. Oh, so there's a lot of things to discuss actually. Okay, so let's import level encoder and one hot encoder. Okay, so what all things you see as what to say, and one hot encoder, gender, employer category. I cannot define, right? This is a bigger employee, this is a smaller employee. Loan purpose, marital status. Can I say some companies, some bank marital status also a little bit important. Married means they will give one, unmarried zero, because married person have a better chance. They will not go for fraud and all, but we will not consider that. So in my scenario, my employment status, my marital status, my loan purpose, my properties, my gender, my employer category, all these things should come into my what? All this should come by my one hot encoder. So let me just define it. So one by one, we will see employment status. Then we have marital status. All these things I want to categorize into my one hot encoder. Then I have my, okay, let me take as loan purpose. Property, I really don't care where your property is located. Gender, can't be gender bias. Employer category. Okay. So this all I can say that, yeah, this is my one hot encoder. Now, for my label encoder, I can say that my education level, I can say my education level. Then I can say that loan approved. Yes. Loan approved means zero means rejected, one means selected. Yes. One is there. So this all I can definitely keep it. Okay. This one I can definitely keep it. So we have already imported. So let's do something. Label encoder, let us create. So let me have my label encoder variable, and my data frame is right. So Education level is equal to label encoder, and I want to fit and transform. Okay, transform. And what I want to transform? I want to transform my education level to a label encoder. That is what I want to do it. Same thing, I want to do it for loan approved. So instead of this, I can give here loan approved. I can give here loan approved. Okay, let me comment this out. Where loan approved is a problem. Extra space, extra space. Okay, how to test it? Whether it has been done or not, select star from table. Okay, what all we have converted? M education level. Let's go to education level. Can you see? Can you see? We have changed it. We have encoded it. Same thing we have done for loan approved. Instead of yes and no, you can see 0 and 1. Okay. Same thing what I will do is I can do it for one hot encoder. Okay. So let's go ahead and do it. Since I have already imported, I don't want that. And this I have already done. So that's the beauty. So let's do it fast. Okay. If any error, we'll see. So let's put as one hot encoder. And where is my import? I imported right. Let's call him to do my job. Okay. I'll give some parameters. I don't want sparse output and all. I want correct output. Sparse means some vague output. Okay. You have multiple parameters available. Okay. I'll use the minimum one. Okay. I want output to be correct, whatever you are using it. Okay. And handle anyone unknown things, please ignore it. That looks good. So now let's go for encoded, one hot encoded, and same thing, fit and transform all at once. Okay, so what we can do is for testing, we can see what it is giving. Very defined, right? One hot encoder, that is fine. One hot encoder, that is looking good. Free and transfer, DF columns. Which I have already defined, right? Yeah, one hot encoder. Sorry, my bad. Sometimes I forget it, right? I have to Handle unknown. That's correct. Spelling. See, unknown. Okay. Now let me check it. I didn't run it right. Okay, so you'll get some matrix, array matrix. Okay. So this is the output that you will get it from encoded. Okay. This is the output that you will get from encoded. Now let us do it. This encoded, let us put it inside our, okay, where our data set. So let me put it as encoded underscore df. Let me call my data frame. That is my data set, what we have imported. So encoded is fine. Columns, I can put it. Okay. Oh, that is one hot. Get the feature names. So feature names is generally, we are calling it your string columns. Okay. So feature names and output. What are those? Those are my columns. What is my index? Whatever my data frame is setting it, I will use the default one. Now I can call my panda and tell me that, hey, you can concatenate columns is equal to, let me put column, that is fine, and encoded. I'm doing nothing except that, let me concatenate it. Okay, let me concatenate some syntax. I'll definitely miss out. Only after error I'm able to find it out. That's cool. Okay, so I am not nothing doing. I am just calling my. I have never placed columns, right? Okay. So now if I put df dot head, everything should be converted into number. Can you see? Loan purpose, education, everything has been converted to number. This is what we have done here using one hot encoder. When to use one hot encoder? When to use label encoder? Now you are more comfortable than me. Okay, fine. Now we are going to do the one of the most important step, that is identify the relationship between the variables. To identify the relationship between the variable, we are going to use something called as correlation heat map. Okay, we are going to use something called as correlation heat map. What is the purpose of correlation heat map? The purpose of correlation heat map is it gives you a visual graph. It uses some nice colors. It is going to represent values in a table, in a matrix. So it is going to give you relationship between two variables. Example, if my credit score is, how my credit score is related to applicant income. Okay, or loan approved is related to my applicant income, or loan approved is implemented with credit score, or loan approved is done with whatever relationships you want to establish between two variables. You want to check it, you can do it through the heat map. So it will give you a nice visual graph that will represent that what is the relationship between the variables. Variable means your columns, your data. Okay, that is what the use of correlation is. Correlation heat map gives you three values. -1, strong negative correlation. 0, no relation. 1, positive 1, strong positive correlation. Very important to understand. Another 10 minutes, you will get all the three terminology, why we are doing it. Okay. So ideally, heat maps are used to detect feature relationships, column relationships, variable relationships. understanding the data patterns quickly. Okay. So let's go ahead and let's just do it. Another 5 minutes, you will have a complete clarity why I have used it. So let me have do some columns plotting, select some data types. So I want to, since now all should be number. Okay. One thing more you can check here. Suppose you want to check the info. Can you see any object now? Everything has been converted to numbers. You can't see any objects because using encoder, we have done that. Come to this point now. So include equal to number means everything it will be included because now everything is a number. Let us have a correlation matrix and you want between all the columns. To create it. Okay. And using this, you are going to plot a figure. PLT means plot a figure. Okay. Figure size, you can give whatever you want so that it looks good for you. That's fine. And we can create again, C1 will come, create a heat map. How to create a heat map? You need correlation matrix that we have already given as an input. Any annotations? Yes. Have a true. Okay. I can have couple of important parameters that till 2 decimal point, you can display it. And these are like how you want. Okay. The theme and all. So I'll put something as cool warm. Generally, I use it. Okay. Let us see if we have done correct. Okay. Can you see? So what it is telling? It is telling wherever you see red graph 1, that means its relationship with itself. So applicant income is in the first column, right? If you see co-applicant column is in the second one. So it is telling you the score. The score will be between -1 to +1. So +1 base highest, strong relation. Definitely with its own table, it will have its own column, it will have a good relation. Correlate applicant, it will have good. Age will have a good. So wherever you see it, one red mark, that means it is with the same column that you have. Okay, you can identify this. You can identify this. Can you see? First is applicant, then co-applicant. So relation with itself is red, my dear friends. Okay, relationship itself is red. Now let's sort this column and get some good numbers to understand, which will give you one of the very good concept. Okay, let me check with loan approved. Everything is with loan approved. Okay, loan approved, and let me have short values, and I want to have short values, my bad, and I want to put in descending order. Okay, so ascending is equal to false. Okay, now this data is everything for you. You can see a number has been assigned. What with what respect? With loan approved. So all your variables, what I have done is this graph was difficult to understand. Guys. Okay, going inside deep looks very disgusting. So what I have done is I have told my columns that hey, I want to find your relationship with loan approved in a descending order. So first loan approved itself has come because it's the last column, like highest value. So you have got this. So loan approved with loan approved, always one, right? Same column with the same relationship, always one. Second is what? Credit score. Credit score is what? 0.5. 0.45. Why it is 0.45? It's the second highest. Can you understand? More with this, we can understand that. See, whenever you get a positive correlation, understand it the best concept. Whenever you get a positive correlationship, that means, example, if I take x1, x2, x1 increases, x2 increases. Here, what it means is positive correlation means that if credit score will increase, your chance of loan approval will increase because this is being plotted with respect to that is a relationship with loan approved, my dear friend. If you have understood this, you have understood a very good concept in the most simplest way. What I'm telling you here is credit score is positive score plus 0.451175. Now, what will happen here is if your credit score is more, your loan approval chances are more. Let us see the negative value. See the age. Does it matter that if my age is more, my loan approval chance is more? No. Okay? No, it's not like that. Wherever it is negative. So age less means more chance of loan approval. Wherever negative means inverse proportion with your output. In my this case, output is loan approval. Imagine you have debt to income ratio. It will always be negative. Why? Because and highest, more number of loans you have taken, that means lesser your chance to approve the loan. So negative value or negative correlation value is going to tell you that what your chances is inverse. Everybody clear with this particular concept? If you have understood this concept, it's one of the most important concept that you will ever get it. Are we all on the same page, my dear friends? Are you there with me? You have seen my intensity. I have not gone down. Okay. I have not gone down, my dear friends. Very good, Tejas. Okay. Now we will do the thing that we have imported, friends. What we imported, I told you, right? Now you need to segregate your data. That I have analyzed all my data. Entire data has been analyzed. Now my job is to differentiate between my training data and my testing data. So that's the important thing. Using sklearn library, I am going to do it. So it's very simple. Let me do it in a faster manner. Okay. So training data, do I need to give him loan approve or not? I don't want to give him something called as loan approve or not. Okay. Because I want to calculate him. Already I have given him. So let me drop it. Why my keyboard is so good? Okay. So axis is equal to 1 and x-axis, I don't need that. I only need it in, okay. I don't need loan approved to be compared with loan approved. Okay. So loan approved is my this data and all the other columns should compare with it. So from x-axis, I am dropping it. Y-axis, I have it. Okay. Now I can tell, let me see my head. Okay. So my y-axis has only loan approved now. Okay. So y-axis has only loan approved now. You can see it. Okay. Now what I'm going to do, I am going to split my data. So this is all the terminology. X train means this will be x-axis columns which I want to give it to train it. There will be testing also. So that also I'll give. And same thing, y train and y underscore test. Okay, so let's train underscore test underscore split. Okay, X and Y is there. And I want to, I'll just tell you what I am trying to write it here. Let me keep it something as 0.2. That's fine. And let me have random state is equal to 40. Okay. What I'm trying to do here is, okay, what my intention here is that, okay, so I am defining my data, that is some data I want it to be into training model, some data into testing model. Okay. So these are nothing but I have defined some variables, some options available. So Xtrain means training data, testing feature, training data, training feature. Okay. All these things I have done it. 0.2 means, my dear friend, that your testing data will be 20%. 0.2 means 20%. So testing size, I am, if you have 100 rows available, 80 will go into training, 20 will go into testing. Okay, that's what it's mean. Random split means, okay, so it's just a random number I have given that every time you split it, it is going to produce some different train or test data. Okay, it's arbitrary that I have used it here. Fine, let's go ahead and yeah. So I just want to learn it. Okay, let me, I don't need this right now. I've defined it. Sorry, my bad. Run it again. Got 10. Okay. Test size is, just let us put in. Okay. Now I can just go ahead and suppose. Okay. So you can see that this is your testing data. Okay. This is your testing data that we have actually taken out. Fine. Now let's go ahead and write the code for actually do it. Fit it, do it, all these things. So I need a library. Let me go. I have something as sklearn. I think standard scalar something I need it to scale up. Yeah, that is correct. Okay, let me go ahead and let me import it. Fine. Now let me declare a variable so that I can use this library standard scalar. Okay, let me have from what is my train data. Let me scale it up. Let me use scalar dot fit underscore transform, and it should be taking my training data because I want to train it up. Similarly, for this, and I can use the same thing, scalar, since it is for testing, I am just going to use it. Okay, so that is fine. And we can check it also. Okay, any variable you can test it. Okay, so your testing value has been assigned and it has been kept secretly. Now it's the time, the last step where we will train and evaluate our model. So I am going to use something called as logistic regression. When you come to the session, okay, in the class, initially we will first learn what are the different techniques that are available, different algos that are available to train your model. Logistic regression is one of them. KNN is one of them. Okay. So there are multiple things available. Bias, naive is another one of them. Okay. Decision trees, another one of them. Okay. So now I am using the simple one that is logistic regression. Okay. So why I am going to use logistic regression is we will see in a couple of minutes. Okay. So my idea is that we will use right now as logistic regression. Okay. So we will train it using logistic regression, friends. Okay. So let's do it and let's run our last piece and see what all information we can gather. Okay. sklearn. I also don't remember it. So logistic regression. Let me. Do I have? Okay. Let me import it. Okay. Now I have to. Is it giving me correctly? Okay. Leave it. It's giving too much. Let me use it. Okay. Now we are going to train and evaluate our model. So logistic regression is one of the technique that I'm using. The code has already been written. Internal working, I can teach you in class only because, or I'll take a workshop later on to understand how the code has been written. For that, you need some mathematical concept. But this differentiation, your probability. Okay, that is why people teach you. Okay. So now let's import something called as confusion matrix. I will tell you why this. Accuracy score, precision score, recall score, and even I don't need all of these, but just for your information, I am using it. Okay, now let's call my logistic regression model. Okay, so that is your logistic regression. Now all those methods are available here. Now I can call my log model and fit into, I can give him my training data. What is my training data? X train scale. I can give it to my model and I would have written what? I also don't know. Y underscore train. Let's give it. Okay. So I've given it. Now I would like him to start predicting it. How you can predict it? By using the model that I am giving you to train. So what you can do is using this, you can start predicting. And to predict, I want you to use testing data. Whatever data you have been trained on, see, understand the concept. Okay, limited time, I can teach you this much. Okay, so what do I mean by predicting and why I have bifurcated it? If you understand the concept, beautiful concept. See, whatever data you have been trained on in your exam, you should not get that. Okay, that's not a true exam for you. Okay, that's not a true exam for you. So imagine in your class, if teacher teaches you 100 questions, same question comes in the exam. What testing we have done? What I am going to evaluate according to you? Okay, nothing. You know everything. So what we have done is we have segregated our data. That 80% data I will give you for training, 20% data I am giving you for testing. So you train yourself and then predict yourself giving this particular extra. That is your true testing data. Okay, that's it. Want to do. Now we want to evaluate. Okay. So definitely I want to evaluate means I need to print that how my model is evaluating. Is it giving me good accuracy? What it is. So I can give it as this is just printing. Okay. You can give anything you want. Similarly, I can give to print another 5 minutes. Okay. We are done. You just need to understand this very important thing and what we have actually predicted. What is my precision? Let's me called my precision score. Let's see how my model is performing. That is what we'll see, right? Whatever we have trained him, whatever data we have given him, what he is going to do. Let me just keep on copying pasting. Let me put a recall. Same thing again, right? I have to just type it. I want to show you everything. Oh my God. Yeah, fine. So it's just about all these codes now. Let me give some two, three. Oh, sorry. It went enter. Okay. I can use something called as one score. Okay. And I can use something called as accuracy score. And I can also use some confusion matrix. Okay, good. Yes, my dear friend, I have forgotten the comma. See, so nice it is telling. Okay, now you can see. So this is a model I have used it. The precision of this particular model is 78%. Okay,